Another day, another story. In today's hyper-connected world, the internet stands as a testament to human innovation and creativity. It has transformed every aspect of our lives, from the way we communicate and share information to how we conduct business and access entertainment. To truly appreciate the marvels of the internet, we must embark on a journey to understand its intricate workings and the remarkable technologies that power it. Chapter 1. The Birth of a Digital Revolution. The story of the Internet's origin is a tale of visionary thinkers and technological innovation. It was a time of immense geopolitical tension, the height of the Cold War. As the world watched the United States and the Soviet Union engage in an ideological battle, a different kind of war was unfolding, a technological arms race to develop groundbreaking communication systems. Amid this backdrop, the United States Department of Defense's Advanced Research Projects Agency, ARPA, conceptualized a revolutionary idea: the creation of a network that would connect computers and enable them to communicate with each other. This network, known as the ARPANET, laid the foundation for what would later become the Internet. In 1969, the first successful message transmission occurred over the ARPANET, connecting computers at the University of California, Los Angeles, UCLA, and the Stanford Research Institute. This breakthrough marked a pivotal moment in human history, a moment that would shape the future of communication and information exchange. The 1970s saw the development of crucial protocols that paved the way for the Internet's expansion. Visionaries like Vinton Cerf and Bob Kahn formulated the Transmission Control Protocol, TCP, and the Internet Protocol, IP. These protocols introduced the concept of data packets, which are discrete units of information that can travel independently across networks. This breakthrough allowed for more efficient data transmission and laid the groundwork for the seamless exchange of information across the Internet. Chapter 2. Pioneers and protocols. At the heart of the Internet's evolution were individuals whose innovative thinking and collaborative efforts propelled its growth. Vinton Cerf, often referred to as the father of the Internet, played a pivotal role in shaping the Internet's communication protocols. His work on the TCP, a protocol that ensured the reliable delivery of data packets, revolutionized how computers communicated. Bob Kahn, a brilliant computer scientist, collaborated with Cerf to develop the TCP, IP protocol suite, a set of rules that govern the transmission of data across networks. The TCP, IP protocol suite introduced a layered architecture, with each layer responsible for specific functions. This modular design allowed for flexibility and scalability, ensuring the Internet's ability to adapt to changing technologies and requirements. The 1980s marked a significant turning point for the Internet, as the TCP, IP protocol suite became the standard for communication on ARPANET. This transition solidified the foundation of the modern Internet and set the stage for its exponential growth. Chapter 3. Building blocks, data packets and routers. At the core of the Internet's architecture is the concept of data packets, small units of information that form the basis of digital communication. Imagine data packets as digital envelopes, each containing a fragment of information. These packets are the messengers of the digital age, shuttling between devices and networks to deliver messages, images, videos, and more. To understand the journey of a data packet, let's take the example of sending an email. When you hit send on an email, your message is broken down into smaller packets. Each packet is labeled with its source and destination addresses, ensuring that it reaches the intended recipient. The packets take different routes through the Internet's complex network of routers, which are intelligent devices responsible for directing traffic. Routers play a crucial role in the Internet's operation. They analyze the destination address of each packet and determine the optimal path for its journey. Think of routers as traffic controllers in a bustling city. They make split-second decisions to ensure that data packets reach their destinations efficiently. This dynamic routing process allows for efficient data transmission, even in the face of network congestion or disruptions. The Internet's global reach is a testament to the collaboration of routers and their ability to navigate complex paths. As data packets travel through different networks and routers, they may encounter different types of technologies, such as Ethernet, Wi-Fi, and fiber optics. Despite these diverse technologies, routers ensure that data packets seamlessly traverse the digital landscape, ultimately arriving at their intended destinations. Chapter 4. Navigating the digital landscape, IP addresses and domain names. In the expansive realm of the Internet, where millions of devices are connected, a system is needed to uniquely identify each device. This is where IP addresses come into play. An IP address is a numerical label assigned to each device on a network, serving as its digital identity. IP addresses are divided into two main types, IPv4 and IPv6. IPv4, the earlier version, uses a 32-bit address format and has limitations on the number of available addresses. As the internet expanded, the need for more addresses led to the development of IPv6, which uses a 128-bit address format. IPv6's vast address space ensures that the internet can accommodate the growing number of devices, from smartphones to IoT devices. While IP addresses provide the foundation for digital communication, they are not the most user-friendly identifiers. Imagine having to remember a string of numbers for every website you visit. To bridge this gap, the Domain Name System, DNS, was introduced, a system that translates human-readable domain names into IP addresses. Domain names, like www.example.com, serve as the familiar addresses we type into browser. Behind the scenes, the DNS translates these domain names into corresponding IP addresses, allowing computers to locate the desired resources. The DNS operates through a distributed network of servers, each responsible for resolving domain names within specific zones. Consider the DNS as a global phone book, connecting domain names to IP addresses. When you enter a domain name, your request is sent to a DNS server, which searches for the corresponding